So our next step will be, I'll show you that a search engine is also a NoSQL database, which not everybody realizes, and that will give you some more ideas on what you can do with that. Since we're having a natural little break here, if you want to type any questions about the first section, which was Elasticsearch as a data store, then you're welcome. So we said Elasticsearch is a data store, but it is also NoSQL. How is that? That is because it uses essentially the same format to store the data. If I draw up a comparison, like here on the top, when you store a document in a search engine, you also store essentially a record. That will be right here, document. The document in the search parlance is the same as the row in SQL. The document has a key, a primary key, and the table very often has a primary key. The document that is being stored is essentially a record, so it has different fields. And in the SQL world, it has columns. So far, we do have a parallel between a search engine and the SQL. But if we go a bit down, we can see that there is more parallel with the NoSQL. That is because in a NoSQL, there is this one row key, which is a must. It's not the same as an index. And it also has fields, which is similar to NoSQL because these fields are, of course, present in a NoSQL. You can do any kind of a field, unlike SQL, where you have to have it structured. In the NoSQL world, you can put any field name because anyway it will be stored as a column name and column value. Well, pretty much the same story happens here on the left with the search engine. You put a field, which you decide what it is. It may be all of the text in the document, but it doesn't have to. It could be the author of the document. That's also a field. The date of last access is also a field, and so on. So you can have these fields, and in the latest version of all of the search engines, these are quickly accessible individually. It used to be that you had to take the whole record of the document, erase it, create a new one, write it. That's a slow process. But today you can update specific individual fields. Once you realize this, then the table at the bottom makes a lot of sense because that's a complete parallel between search and NoSQL. If so, if our search essentially is a NoSQL engine, then what we can do now is we can think of how do we model our data. We know how we model our SQL data. For that, we go to school that's called Normalization School. We also know that once you start doing things in the NoSQL world, they tell you forget everything you learned about normalization because we completely changed that. There is no normalization, just the other way around. We denormalize the data, we store the data 2, 3, 4 times, and we think of what to do. All right, and that's the result. For example, if you want to store, let us say, let's imagine we're storing transactions, and this transaction is a credit card transaction. And then maybe we're storing some special data about these transactions. So in order to create a data model for that, I would immediately go to the classical examples. For example, let's take, that's an example from what we teach. Let's say I want to create a user table and a video table. So how would I have a one-to-many relationship represented in the NoSQL? This shows that the way to do this is to put all of those menus into the same row. So I'll have the user ID and all of the user videos, which might be in hundreds, thousands, and maybe even millions, will be in the same row. That's not a problem for NoSQL because it can have any fields that you want. So that is how you would represent a one-to-many relationship in the NoSQL. In the same way, you can then answer any other similar question. You'll go to best practices in the NoSQL. Actually, when we teach it, it's a lot of fun because we divide people into groups and they need to design the best possible tables representing these relationships. And then after a while, they say, oh, that's what it is. That's not all that hard. Now I understand. That is what you get. So you create a table, and then you can store not just individual documents, but now you store a certain schema. You can find all of the, let's say, notifications that belong to that particular transaction and the other way around. So good, you stored it. You can get one document at a time. It is searchable. You can do the text search. You can look for bad guys. For example, recently I watched a video about one pretty bad guy. He was a carder. He stole like about $30 million worth of money and did it with the card selling business. So he was very significant. It's interesting that he did a lot of things just by himself. Once they got him and put him into prison, was a Russian guy. So that made Russia very upset, by the way. So that all pretty much stopped. The reason I'm saying this is that this guy wasn't careful enough with operational security, and he used his username. So one search would actually found him, and that is actually how they found him in the end. So search is a very powerful tool in addition to your analytics. But still, then you may want to run analytics. So again, you will say, okay, I know how to do this. My search engine is just a NoSQL engine. And with NoSQL engines, I know how to do this. For example, here's an example on Cassandra. On the left here, I have that part of the engine that's responsible for real-time transactions. On the right here, I have that part of the engine that's only doing analytics. That way, if I have an analytics query, it goes to the right part of the cluster. If I have a transaction, it goes to the left part of the cluster. And the connection between them makes sure that it is all balanced, that it is all replicated. So you can do the same thing with the search engine. And what I'm showing here is the cross-pollination. The ideas that you get from NoSQL, you can then move them and use them in the design in the search engine.